This is section 3.5. It's called Graphing Technique Transformation. We're on page 262 and we're going to look at that blue box. So if we look at the blue box, if you have a k after whatever the parent function is, you're going to raise the graph up that many numbers. If it's a minus, then you lower it down. So when you're raising and lowering, this is on the y-axis. Horizontal shift, these are the parts that would be inside parentheses. If it was an absolute value, it would be inside the absolute value. If it's a plus, you go left that many units. If it's a minus, you go right that many units. If there is an A in the front and it's greater than 0, then you have a vertical stretch. If it's between 0 and 1, then you have a vertical compression. If there's no number in the front, then that just means that it's normal size. Okay, this is the one that's a little bit different. If the A is inside parentheses, then that means you have a horizontal stretch if it's between 0 and 1, and a horizontal compression if it's greater than 1. Okay, we did not talk about this if you had me last year in class, so this is new. Okay, moving this up. If you have a negative in front of your problem, then you reflect across the x-axis. That means that the graph would open down. This one is new. If the negative is inside parentheses or inside the absolute value bar, then you reflect the graph about the y-axis. Okay, so they look different. Okay, so we're just going to recap all of this real quickly, just kind of condensed down. Okay, so if we have y equals a parentheses x plus h squared plus k, a in the front, if it's positive, you're going to open up. If it's negative, you're going to open down. Okay, and that would be your reflection across the x-axis. All right, also looking at the a, if a is greater than 1, you have a vertical stretch. And you may remember S for skinny, so that means you're going to have a skinny graph. If A is in between 0 and 1, and remember, we ignore the negative, so if you wanted to do an absolute value around the A, you can. The negative only would tell you it would open down. So we ignore negatives, that would be a vertical compression. Which means your graph would be fatter or wider. If there's no number in the front, then we would just consider that normal size. So it's not fat, it's not skinny, it's just your average normal size. Okay, looking inside the parentheses, if it's negative, you're going to go right. If it's positive, you're going to go left. This is backwards from the coordinate grid. Looking at your last digit, if it's positive, you're going to go up. If it's negative, you're going to go down. Okay, so this is the majority of the blue box in a nutshell. All right, we are going to work out question number 10 in the book. Okay, question number 10 gives you an absolute value. It looks like this. Okay, and this is supposed to be a V shape. So if you have a V shape, then that means it's absolute value. Okay. Then you needed to look and see what did that graph do. Well, it shifted up 2 units. It didn't shift left or right, was none. It opens down. And if you look and you're going down 1 and over 1 and down 1 and over 1 and down 1 and over 1, then that means it's normal. So this is normal size. Okay? Because we went down 1 and over 1, down 1 and over 1. So we're going to write an equation from there. So since we open down, we start with a negative. Since it's normal, there's no number there. You're going to have an x right there. We did not go left or right any, so we're just going to end the absolute value bar. And we went up 2 units, so we have a plus 2. If you look on your multiple choice answer, this is D. All right, next one we're going to work out is number 29. Okay, 29 says find the function that is finally graphed after the following transformations are applied to the graph y equals square root of x. So y equals the square root of x. That's your parent function. Okay, so 29 says we need to reflect about the x-axis. Okay, so if we want an x-axis reflection, we need to have a negative in front of your equation. So that's what that one's going to do. Number 2, shift up 2 units. Okay, and since we're shifting up, it needs to be outside of your square root. So we're going to work off of this one, and it's going to be a plus 2 on the end there. Okay, and then the third step, which is your answer step, shift left 3 units. Okay, so left has to go inside the square root, and it's going to be opposite from the coordinate grid. So since we're going left, we're going to add. So we're going to have x plus 3 and then the plus 2 on the outside. And this guy here is the answer. All right, and the last one we're going to do is number 42. So 42 says graph each function using the techniques of shifting, compressing, stretching, or reflecting. Start with a graph of the basic function, show all of the stages. Be sure to show at least 3 key points, find the domain and range of each function, and then verify with a graphing utility. Okay, so 42, g of x equals x to the third minus 1. Okay, so you start and you say, which way does this open? So this one's going to open up, and for up, that just means it's going to be normal looking. So a normal, I'll just do a mini sketch over here. A normal x to the third is going to look like this. If you had a negative in front of x to the third, that kind of flips it going backwards like that. So ours is going to look like that. Because it doesn't really open up because it's not a parabola or a V shape. But it's going to be the normal one like that one. Okay. So all the minus 1 is going to do is just make the graph go down 1. Left and right would be none. And there's no number in the front here, so it's going to be a normal transformation. So basically, the only thing we need to do is go down 1. So normally that graph would go up like that. So we're going to go down 1 and then do your up. This is going to look like that. Okay, domain, negative infinity to infinity. And since the arrows go opposite direction, the range is the same thing. Negative infinity to infinity. Okay. All right. Have a good night.